What's up, Algebra 2 students? We are going to start slowly, okay? Our first lesson in our first unit is reviewing key things from middle school. And our entire first unit here in Algebra 2 is actually reviewing like one of the first units from Algebra 1. We are going to go back to basics. I don't want you to show up feeling like you have no idea what's going on. It's already new stuff. We are going to keep it simple, ease our way into things. You guys learned Algebra 1 during the pandemic year when you were learning remotely. Not sure if it was very successful. So, here's some crucial things to remember from middle school. Easy things that help make life easier in algebra. Working with numbers. Okay, I'm going to help make sure you understand. Like this will help you work with numbers if you know this. For example, like subtraction. What I like to tell all of my students, regardless if they're in Algebra 1, middle school, or calculus, if you are to subtract, it is the same as if you add the opposite. Okay? Now, for example, I'm just going to show you using like manipulatives really quick. If I have 5 pluses, 3, 4, 5, and I take away 2, so I'm going to just erase 2. 1, 2, 3, 4, I have 6, sorry. So here's 5 pluses. If I take away 2, I have 3. Okay, great. Well, if I have 5 pluses and 2 negatives, and I add those together, whenever there's a -1 and a +1, they cancel out to be a 0. So it ends up being the same thing. Maybe that's not necessary, 5 minus 2, to turn into 5 plus -2. But when subtracting negative numbers, that's when it gets confusing. Like a negative number is kind of like having a whole. If we like take away a whole, what happens? If we have a bigger number that we're taking away than a smaller number, what happens? So I always tell students, turn things into addition by adding the opposite. 3 minus 5 is the same as 3 plus -5. If you want to, 1, 2, 3 positives, 1, 2, 3, 4, 5 negatives, every single plus and minus combination creates a 0. So all 3 of the pluses go away and 3 of the minuses go away, leaving you with -2 left. We have 2 more negatives than we have positives. When we're subtracting negatives, turns out, this is tough to understand, but if you switch it to add the opposite, you realize, oh, subtracting negatives is just like adding a positive. So it's 3 plus 5, which is 8. When you have multiple things, always tell all of my students, I don't care who you are, calculus or middle school, add the opposite. This is 2, -4, +4. You can add things in any order that you want. A -4 plus a +4, that's 4 negatives, 4 positives, that's 0. Add 2, get 2. Subtracting from negatives, don't worry. I'm adding more negatives. I have 4 negatives, and then I have 13 more negatives, right? How many negatives do I have now? I have 17. There's no canceling of positives and negatives. It's just I have more negatives. -2 minus -3, subtracting a negative turns out is just like adding a positive. I'm not even going to show you how to subtract the negatives. It's like, it doesn't make sense. You'd have to like take away things or like the manipulation, showing it with pluses and minus with subtraction. It's tough to do. It's easier to just be like, oh, subtracting a negative is the same as adding a positive. 2 negatives, 3 positives, 2 of them are going to cancel. I'm left with 1 positive. Okay. It's tough to kind of describe this stuff with multiplication. So I'm just going to make sure you know, like, A positive number times a positive number is a positive. But when we multiply a negative by a positive, there it becomes negatives. It's like almost the sign just gets changed. But a negative times a negative is a positive. In a famous movie that I forced my calculus students to watch, the teacher in the movie is like, a negative times a negative is a positive. A negative times a negative is a positive. And he makes his students repeat it. And then he asks at the end, why? And I've always thought, like, what is a good explanation of like why is a negative times a negative positive? And honestly, I can't think of a good one. So maybe you guys can think of a good one or look up, Google it. Why is a negative times a negative a positive? It's like the opposite of analysis. Maybe that's a good explanation. Like, I'm not hungry. Oh, I'm hungry. I don't even. Yeah, it's tough. Anyways, you should be comfortable with some multiplication things without using a calculator. But if you're not, it's okay. We will have access to our calculators for most of this class, not for everything. This stuff we expect you to do. You know how to do 7 times 8? I think of 7 times 7, and then I add 7 more. You do that. You have your multiplication facts, maybe you know. I know 7 times 7 is 49. So then I add 7 more, and I'm thinking, oh, that's got to be 56. Negative times a negative, positive. You don't have to put the plus next to the positive. One group of 12 is just 12. The opposite of one group of 12, put like a not. Not hungry. I'm not hungry. Not hungry. I'm not hungry. Not hungry. Oh, I'm hungry. If I'm not hungry. I'm not hungry means I'm full. If I'm not hungry, that means I'm still hungry. I don't know. That's confusing. Uh, Multiplication can be done in any order. I'll show you. Negative 2 times 3, negative 6. Times negative 5. A negative times a negative, positive. Negative times a positive, negative. I could do 3 times negative 5 first if I wanted to. Well, let's do 3 times negative 5 first. I get negative 15. Leave the negative 2. Negative times a negative, positive. You could do the first one times the last. Now, this only works for multiplication and addition. Don't you dare do this with subtraction. It doesn't work. Negative 2 times negative 5 is positive 10. Positive 10 times 3 is 30. Cool. So there you go. Multiplication, subtraction. We're going to see fractions this year. Just going to remind you how to work with fractions because maybe you forgot. Maybe it wasn't like an emphasis in geometry. 2/3 of something. You know, you're cutting a pizza into slices. What is it equivalent to? Just understand that if you take any number and multiply it by 1, it's not going to change it. Okay, multiplying something by 1, I have like one group of 5, it's 5. If I have one group of 2/3, it's 2/3. But understand that 1 has many different appearances. 1 can look like this fraction, 2 halves. 1/2 is half of a pizza. 2 halves is a full pizza. It's 1. 3/3. 4/4. 5/5. That's all equivalent to 1. You have all of your pizza slices cut in certain ways. So I can decide to multiply this by what is a version of 1. It's still like what's one group of 2/3. It's still 1 2/3. But multiplying by 2 over 2. Now, with multiplication, we multiply straight across. There's a way for me to explain that I'm not going to show you. Instead, I will just multiply 2 by 2 to be 4 and 3 by 2 to be 6. 4/6 is the same as 2/3. They are equivalent. Okay, cut a pizza into 6 slices, take 4 of them. Those 4 slices are the same amount as if you cut a pizza into 3 pieces and you take 2 of them. They're the same. It's going to be the same amount of pizza. Okay? This can be done also to simplify. Multiplying by 1 doesn't change anything. Dividing by 1 doesn't change anything. I can choose to divide something by 2 over 2 or 3 over 3 or 4 over 4. You can choose to divide by 4. As long as you divide by 4 divided by 4, you're good. And this turns into 8 divided by 4. How many times does 4 go into 8? 4, 8, twice. How many times does 4 go into 12? 4, 8, 12, 3 times. And boom. Turns out 8 twelfths is the same as 4 sixths, is the same as 2/3. It's the same amount of pizza. All right? And where this helps is like, if you were asked, hey, you got 2/3 of a pizza and they have 8 twelfths of pizza, how much pizza do you have? You can, it's tough to add. It's like, these are big slices. These are thirds of the pizza. These are twelfths of the pizza. The only way I can add them is like I know how many they are in terms of each other. Like, it'd be nice to figure out like how many is 2/3 compared to twelfths. Like if you make smaller pizza slices and you make twelfths, how many twelfths are in a third? You know what I mean? So what we like to do is we like to understand that when you're adding fractions, adding pizza slices, they got to be the same amount. So I'm going to take these thirds. I'm actually going to slice them up some more and make them into twelfths. We call this common terms or common denominators. I'm going to turn these 2/3 into twelfths. I'm going to cut it up, make it even skinnier. The only way I can do that is if I multiply this 3 by a 4. I can't just multiply the 3 by the 4 because we need to multiply by a version of 1. So this is when we multiply the top and the bottom. This is 8 twelfths. Oh, okay. 2/3, 8 twelfths, they're the same. We just talked about that. But now what's 8 twelfths plus 8 twelfths? Okay, let's think about this. 1/12 is a very skinny kid size, like toddler size pizza slice. I have a 3-year-old. We cut him really small pizza slices. He would get a 12th of pizza. He could eat 8 twelfths. Think about this not as a number, but as like an amount of twelfths. 8 twelfths. Well, if I have 8 twelfths and you have 8 twelfths and we combine them, what do we have? Well, 16 twelfths. Sometimes it's confusing to work with fractions. It's like, oh, when I'm multiplying, I multiply the top and the bottom. But when you add, it's a little bit different. It's like you have an amount of something. I have 8 twelfths and 8 twelfths, and I have 16 twelfths. If you try to think of this in like real world situations, it sometimes helps you when you manipulate. I could have done that. There's another way we could have done that. We could have turned the 8 twelfths into 2/3. And it turns out it's 2/3 plus 2/3. If I have 2/3 of pizzas and you have 2/3 of pizzas, how many do we have? We have 4/3 of pizza. And we can see that that's what we would get if we took this and divided the top and bottom by 4. 4/3. Okay, so boom. If I have 3/4 and I want to take away 5/4, well, I'm taking away more than what we have. Hold on, I got to pause this video because I got an important person walking through this door. All right, back to it. So, again, don't think about subtracting, add the opposite. I have more negatives than I have positives, so it's like we'll end up with -2/4. Okay, like 3 positives cancel with 3 negatives, leave it. It's like we end up subtracting 3 from 5 kind of thing. But -2/4 I can change into -1/2 by dividing the top and bottom by 2. Same thing here. Oh, we have 25ths and we have fifths. There's two ways to do it. I could have done that here. Let's split it off and show you two different ways. Again, it's tough to add and subtract these things because they're not the same like slice. You know, a 25th is very skinnier than 1/5 of pizza. Like I would never want to try to cut a pizza into 25 slices, but maybe I could you could try. That'd be really tough to do, actually. But what could we do? Well, we could change this 1/5 into 25ths. Oh, 1/5 is equivalent to 5 of your 25ths. But it'll be negative 5 of your 25ths. And then I'm going to subtract the negative. We know that's the same as adding a positive. Make that change so that you do it. Oh, hold on a second. You have negative 5 25ths. I have positive 5 25ths. We got nothing. We got 0. Like you're taking away the same amount as you're adding kind of thing. And that's easy to see once we turn it into positive. The other thing to do is instead of changing this one, we could have changed this one. And then you could simplify this and we find that they are like terms. They are similar. They are in fifths. So I got negative 1/5, and this is minus negative 1/5, which is the same as plus positive. Okay. Now, here's when it gets tricky. You have 2 of these thirds. You cut the pizza into 3 slices. You have 2 of them. That other person's got 3/4. They cut it into quarters, okay, which is easy to do, cutting things into quarters. Just like 1 slice across, 1 slice across. You have 3/4. I have 2/3. How many do we have total? Well, it's like very tough to make these thirds into fourths. Like I can't multiply 3 by a number that looks nice, so I can add a 4. Same, I can't turn 4 into 3. I can't divide 4 by a nice like whole number. So we have 3. So what we're going to do is like find some common ground, some number, some amount, some slice that we can both kind of compare this to. And an easy thing to do is just to like, you know, kind of let the 4 help with the 2/3 and have the 3 help with the 3/4. It's multiplying by the other's denominator. Again, a version of 1. And this is 8/12. Okay, that's cool. We talked about how you can take 2/3 and make it 8/12. Well, 3/4, when we multiply the top and bottom by 3, turns into 9/12. Oh, look at that. Now we have something that's similar, okay? Skinny 12ths pizza slices, but I have 8 of them. That's equivalent to 2 1/3 of pizzas. And then you took 3/4 of a pizza. It's the same as 9 skinny 12ths. Cool. Now we have these skinny slices. We can figure out how many of these skinny slices do we have. Well, I have 8/12 and 9/12. That's going to be 17/12. So I have more than a pizza. Look at me. All right. Think about this stuff like real world. Okay. Here's some more examples. I'm just going to do a couple of them for you. Starting with this one again, this is a good one to do. A half a pizza and a fifth of a pizza. Well, make them like each other. Make them into smaller slices, but have more of them. 5/10 of a pizza is the same as a half of a pizza. If you cut the pizza into 10 slices and take 5 of them, it's the same. 2/10 of a pizza is the same as 1/5 of a pizza. Cool. 7/10 total. All right. All of them are similar until we get to the ones on the bottom. So let's do one more. I'm going to give this a 3 to turn these into 21sts. Wow, that's small pizza slices. And I'm going to give this kind of like a 7 to make this a 21st. When you multiply by the other's denominator, you always get like a common, you always get like a common amount, okay? So I have 9/21 and negative 28/21. Well, I have more negatives than positives, so we need to kind of take away some of the negatives, and we end up with negative 19/21. Just 28, take away 9, take away 8, and 1 more. Now, what happens if you have a number plus a fraction? So I have 2 whole pizzas, and you're giving me a fifth. A lot of you want to do 2 and a fifth. That's fine. However, like in my calculus class, there's no such thing as a mixed number. It's very good for baking, like 2 1/4 cups of flour. And it's easy to understand. You get your 2 cups, and then you get your 1/4 cup, and you throw that. But in math, sometimes we don't like that. Sometimes we like what's called like an improper fraction. There's nothing improper about it. But it's just like one number rather than this plus this. So it's important to know that you can turn any number into a fraction just by dividing it by 1. So it's 5 wholes. So I have 2 pizzas. I have 2 pizzas, like oneths. Like I have 2 whole pizzas, right? Instead of halves or thirds. And all of a sudden there we can see, oh, wait, 2 pizzas multiplied by the other denominator is like 10 fifths. Well, if like 5 fifths, you have a pizza, you cut it into 5 slices and you take all 5, that's 1. Well, if you have 10 fifths, that's 2. Makes sense. Then add 1 fifth, 11 fifths. And be the same thing for anything else. 3 fourths minus 12 fourths. Make them the same. Subtracting 12 fourths. Oh, I have more negatives than I have positives. I'll end up with negative 9 fourths. Take away some negatives. The 3 fourths that are positive cancels with negative 3 fourths. What do I have left? Negative 9 fourths. We said this before when we were simplifying. Multiplying fractions is very easy. It's kind of tough to explain. Like it's easy to say like 4 groups of 3. 3, 6, 9, 12. 4 groups of 3, 12, right? But I have like 2 thirds and I have 3 fourths, like a third of a fourth. Take your fourth, cut it into a third, cut it into 3 slices. A third of a fourth is like a 12th, but you have 2 thirds and 3 fourths, so you get 6. So it's tough to explain. So instead, when you're multiplying fractions, you multiply straight across, okay? And if you'd like to, you can then simplify, divide by 6, or what you'll find is like multiplying fractions really can be done in any order, and things can be canceled only over multiplication. We never do this over like addition or subtraction. You're not allowed to. But you could see like, boom, 2 fourths, divide by 2. I don't know. I don't know if I like that, especially at this level. So we keep it simple. Let's just multiply across and then simplify. Biggest number we can divide. So 1/2 of 1/5, 1/10. Split the fifths in half, you get a 10th. Negatives work the same way. See if you can simplify. After that, I can't divide 8 by anything but 4 and 2. Can't divide 21 by anything but 7 and 3. Negatives times negatives are positives. Whole numbers, put them over 1. 3 fifths. Oh, 3 fifths. 3 fifths. You know, I'm doing this, but I don't have to. 6 over 2. It's like 6 halves. 6 divided by 2, 2, 4, 6, 3. You could simplify if you wanted. You know, this is where like math is tricky. There's so many rules. There's so many things you could do, and you get the same answer, which is why like don't be afraid of doing maybe something that you've seen before that makes sense to you. And since there's so many rules, it's a complicated game that we're playing. Division. Dividing is the same as multiplying by the reciprocal. What? Let's turn this into fractions, like 8 divided by 2 over 1, okay? Dividing by 2 is figuring out how many halves are in 8. Or no, it's not. How many times does 2 go into 8? 2, 4, 6, 8. It's the same as like half of 8. 8 of like half of 8. 8 times a half. I don't like dividing. I prefer to multiply by the reciprocal. Now for here, it doesn't really matter. Okay? For this one, doesn't really matter. 3 divided by 6 is 3 times a sixth. It really ends up being, it ends up being 3/6, which simplifies to being a half, sure. It's when we divide by fractions where it's very important. 3 divided by a sixth. 3 divided by it's actually the same as 3 times 6 over 1. This is so much easier. You could think of it as how many times does a sixth go into 3? Well, like, I need to get to 6 sixths to get to 1. 1, 2, 3, 4, 5, 6 sixths is 1. And then I need another 6, so I have 12. That's 2. And then I need another 6 sixths to get to 3. That's 18. That's kind of tough to do or to understand if you're not thinking about it in terms of like pizza slices. If you just follow this, that instead of dividing, multiply by the reciprocal, it's easy to see that, oh, that's 18. So like, I don't like to divide. If I ever see 4 divided by third, I'm just like, nope. It's the same as 4 divided by 3 over 1. 3 over 1 is the same as 3. You can multiply 4 times 3 and 1 times, you get 12. Okay? Dividing, like, makes sense. Like, split these thirds into thirds. Like, divide by 3. You'll see that, oh, well, don't divide by -3. Maybe that doesn't make sense. Instead, multiply by this flipped. Oh, and then we talked about multiplying. We just go straight across. You see, like, split that into thirds, you get a ninth. Don't divide by a 15th. Multiply by 15 over 1. Now, you get -15 over 3. How many times does 3 go into 15? You can simplify this by dividing the top and bottom by 3, but it's like 3, 6, 9, 12, 15. How many times is that? Okay. Looking at it a different way without the division symbol, but like this. Sometimes people say keep, change, change. I don't like that. It's like we're dividing by something. It's the same as multiplying by this flipped. This flipped. The reciprocal is that. This one's tough to see, but this is 2/3 divided by 5. So this flipped, 3 over -1. This flipped, 3 over 5. Put some ones under there if you need to. Oh, a negative times a negative. Maybe you don't see it now, but 8 times 3 is 24. Negative divided by a negative, positive. If you multiply it straight across, boom, we got it. 2 times 3, 5 times 1, 6 fifths. 2 over 3 times 1 over 5. Flip this, 2 15ths if you multiply across. And I think I stop soon. After multiplication and division by 0. Fraction divided by a fraction, again, flip this and multiply. I'll do 2 of 3. 2/3 times 4/5. -1/2 times 8/5. -4/5 times -6 over 1. Put the negative somewhere. Put it up top, put it on the bottom, doesn't matter. Sorry for the gross penmanship. Okay. Great thing to know, multiplication or division by zero. Like think about multiplication as like how many groups? Like I want three groups of 5, 10, 15. It's the same as five groups of 3, 6, 9, 12, 15, right? Let's think about one group of 5. All right, you have one group of 5. You have 5. Okay. Well, what if you have 0 groups of 5? Like you have no groups of 5 at all. What do you have? 0. Right? Doesn't that make sense? So that's multiplication by 0. Whenever you multiply by 0, just 0. You have 0 groups of whatever. 0. Here's another one. 8 divided by 2. Okay, like how many times does 2 go into 8? Or you can think about it this way. What number do you multiply 2 by? How many groups of 2 do you need to get into 8? 2, 4, 6, 8, right? 4 groups. So 8 divided by 2 is 4. Well, let me change up and say, what about 0 divided by 2? How many groups of 2 do you need to get 0? Or what number do you multiply 2 by to get 0? 0. Okay, let me change it up. How many groups of 0 can you get, do you need to get 2? Think about that. How many groups of 0 get you 2? Okay, let's think about it the other way. 0 times a number is 2. 0 times what number is 2? Guys, we can't do it. Can't do it. But you know what? We're not going to say, I don't know. You're going to say, can't be done. Say, sorry, wrong, incorrect, or, yeah, undefined. Like it can't be done. Undefined is a fancy math word we'll use for like something that just can't be done, just doesn't exist. There is no number that you can multiply 0 by. When 0 groups of something is always 0, then like how can you take 0 times something and turn it into 2? Can't. Okay? So it's like how many groups of 7 gives us 0? That's easy. 0. I can do that. 7 times 0 is 0. But what do you multiply 0 by to get 12? How many groups of 0 give you negative 12? Yeah, I can't do that. You can't do that. 0 groups of negative 7, I can do that. How many groups of negative 5 give you 0? None. Negative 5 times 0 is 0. How many groups of 0 give you 9? Negative 9. Can't be done. All right. And that's day 1, reviewing some simple stuff. On day 2, we are going to get into substitution, some order of operation stuff, some like term stuff, okay? And then we get into what I consider day 3/day 4, like a little bit of both. We're going to remember how to solve equations, okay? This is a good way. We're going to have a quiz over this next class, so I'll put up the homework soon. Thanks.